Okay, so the first step here, we have a given amount of H2S and S2O. So we can plug those in, 0.05, 0.05, and 0 of each of the products. Remember, we should also write out K equals Q, so I'm going to do that here. K equals Q is equal to, in this case, I have H2O squared over H2S times SO2, and H2S has a coefficient of 2, so it's squared. Now, S is a solid, so remember, there's no molarity of S, so maybe I'll just put dashes in for S again because it's a solid. It doesn't have a variable concentration. Now, I can do the change row. Remember, just use the coefficient, so this is a product. So it has a coefficient of plus 2x, and we're going to make products and use up reactants, minus x here, minus 2x for H2S, again, because that coefficient is 2. Equilibrium, 0.05 minus 2x, 0.05 minus x, and 2x. Okay, the next step we can do is write the K equals Q expression, again, substituting in the value from the equilibrium row. So this is Kc is equal to 2x squared over, using the bottom, I have 0.05 minus 2x squared times 0.05 minus x. Now we get to the point where we actually have to look at this and try to solve for x. So here we can first say that based on the value of k, k is close to 1, so we expect similar amounts of reactants and products at equilibrium, and we can't approximate. We need to solve this exactly. So I don't know, here's some ideas for how to do that. Okay, so there are a few options in this case. Successive approximations is something everyone can do, no matter what kind of calculator you have. Quadratic, again, if that's applicable, anyone can use the quadratic formula. In this case, that's not applicable because if we expanded this, we'd have a cubic equation, so that one's not an option. So I'll do successive approximations first because that's something that everyone can